Okay, hello guys, welcome back to this video my YouTube channel. So in today's video, we're just going to be looking at this question that was sent to me by a student in GBHS Bonaberi in Douala. So without wasting much time, let's just look directly into the question. The question reads: given that the shaded area of the figure below is bounded by two curves given by x is equals to y squared on a and y is equals to x squared on a. So this is actually the curve. This is the first part, x equals to y squared on a, and the second portion, y equals to x squared on a. So we are asked to show by integration that the s coordinate of the centroid is 9 on 20a. Okay, before solving this question, we have to know in mind that for any plane figure, especially when we talk of a center of mass, you need to know the y coordinate and the s coordinate directly in mind. I mean, those two formulae, you have to know them in mind. Okay, but in this video, we're just supposed to concentrate on the x coordinate. So we're not really laying emphasis on the y coordinate, but I'm sure in some question we're going to also treat the y coordinate. Okay, we know that the area times x bar is equal to the integral from a to a of xy dx. This is standard formula everybody must know. I have to know that the area times x bar is equal to the integral from 0 to a of xy dx. We are interested in only looking for the x bar. So we have to know the area of this shaded area, this shaded portion, and the integral from 0 to a of xy dx also. So the first thing is look for the area. We know that the area is simply the integral of y to x. But who is y? Y is not this guy here. No. Y is equals to x squared on e minus the square root of xe, because we're told that when two curves intersect, because you see that this curve are actually intersecting at this point at 0 and at point A. Yeah, because from here to here is point A. So they intersect at this point and this point. So to look for the area of this curve, we just take this first curve minus this second curve to have the area. To have y, because this y is not really the y that we're going to integrate. No. So when we make the difference between these two curves, there will be our new y. We can call it y0, no problem. So for that, the first one is the first one is x squared on a, and the second is the square root of xa, because if you make y solve the formula here, you realize that y squared be equals to xa and y will be equals to the square root of xa. The reason why I made y solve the formula here is because you cannot really subtract x and y together because they are not like terms. So for you to subtract them together, they must be in terms of x or in terms of y. Get it now? So that's why I made when you make y solve the formula here, you're going to have y is equals to xa, and here y was already made a solve formula. Perfect. So that's it. If you have your y is equals to the square root of x1a minus square root of xe, now you can now go further to look for the area. A is equals to the integral from 0 to a of this dx. Now, when we integrate x squared on a, we're going to have x cubed on 3a, because the power is 2, will be 2 plus 1 divided by 2 plus 1. That's 3 on 3a. Minus, when you integrate the square root of ax, now, you know that a is a constant. So the square root of it is the same as the square root of a times x to the power half. Now when you integrate x to the power half, you're going to have x to the power half plus 1 divided by half plus 1. So half plus 1 is the same as x to the power 1 times x times the square root of x. This is x to the power 1 times square root of x. Now divided by 3 on 2 will be, that means you are going to multiply by the inverse of the second fraction. You're just going to multiply and the answer will be 2 on 3 from 0 to a. Feel free to pause this video and evaluate this integral. You have the same answer. Okay, so let us continue by substituting the boundaries. If you substitute the boundaries, you're going to have if you substitute the boundary a here, you're going to have a squared on 3, and if you do same here, you're going to have 2a squared on 3. Yes, because this actually a times a will make a squared, and square root of a squared is a, and this a will make 2a squared on 3. So the area was found to be a squared on 3 square unit. The truth is that if you compute this, you're going to have a negative a squared on 3. But the reason why I took the absolute value was simply because we realized that our curve, this is our curve here, the curve is found above the x-axis. So when the area is negative, it simply means that the curve is below the x-axis, but it shows directly here that the curve is not found below the x-axis. So that's why I have to take the absolute value of the area. So that's why I have in a square on 3 and not negative a square on 3. Hope it's clear. Okay, so we have look for the area. What we are left is look for the integral of xy to x. So the integral of xy to x is equals to the integral from 0 to a of x times, remember this was our new y here. Yes. So if you open that bracket, we're going to have the integral of x is to the power 3 on a minus x times the integral of x a x. So if you integrate that, but before that, let us just let us do some algebra. The integral from 0 to a of this is same as integral of this minus the integral of this. Remember, the square root of x is same as x to the power half. Then x to the power half times x be x to the power 3 on 2. With a is a constant, and that's what a here. Perfect. So if you integrate x cubed on a, we are going to have x to the power 4 on the 4a because it's x to the power 3 plus 1 divided by 3 plus 1. Same here, 3 on 2 plus 1, we're going to have 5 on 2 divided by 5 on 2. But since we're dividing this by a fraction, we'll just multiply. Will be times 2 on 5. With a is a with a. So we're just left with substitute the boundaries. So if you substitute the boundaries, we're going to have a raised to the power 4 on 4a minus a raised to the power 5 on 2 times 5. I mean divided by 5. Then root a is same as a raised to the power half. So if you simplify this, we're going to have a raised to the power 3 on 4 minus 2a cubed on 5. Because you have a raised to the power 5 on 2 times a raised to the power half is same as a raised to the power 5 on 2 plus half. Then 5 on 2 now plus half will simply be 6 on 2. That's 3. That's by having a raised to the power 3 on 5. Perfect. So if we are subtracting them together, we're going to have xy to be equals to 3a cubed on the 20. That's the integral of xy to x will be equals to 3a cubed on 20. Hope it's clear. Now we have the integral from the to a of xy to x, and we equally have the area. So we can just go and substitute everything in our formula to have x bar. X bar is simply the integral from 0 to a of xy to x divided by the area. So if you substitute everything there, we're going to have 3a cubed on 20 divided by 2a squared on 3. And finally, your answer come out to be 9 on 20a as required. So the most difficult part here was not even integrating. Yes, because I'm sure that if they gave you this to integrate, you could integrate without any problem. But the most, I mean, the idea behind this question was at this level, this level here, to know that y is not s squared on a, but rather x squared on a minus square root of xa. This is the key point. This is the key point here, and this is the point that most students were making mistake. So that's it. That's it. Okay, so I hope that this video brought many clarification and stay tuned.